If you're watching this video, you're probably interested in two things: our capstone project and human rights. So let's talk about both. Our team built a legal aid assistant powered by Gen AI, not to sound smart, but to be useful. We designed it for real people in real situations, like Selma, who uses a wheelchair and was quietly pushed out of her job because the office wasn't accessible. She didn't fight, she didn't even know she had rights. Or Mr. Fati, a 70-year-old who was told to leave his apartment with no warning. He assumed the landlord could, but the law actually protects elders from random eviction. We started by choosing two areas where legal confusion hits hardest: labor law and disability rights. We collected legal documents from trusted sources, then we used PYMU PDF to extract text, cleaned out the noise, and embedded them with OpenAI embeddings. We used vector search with FAISS so that when someone asks a question like, "Can they fire me for needing a ramp?" our assistant finds the most relevant legal documents and explains it in plain English. No PDFs, no confusion, just human answers. We also use few short prompting to keep the bot's tone warm and empathic because justice shouldn't feel robotic. This wasn't just a capstone project, it was a fight to make tech practical, relational, and just. Because Selma and Mr. Fati aren't rare, but with the right tools, they don't have to be powerless. Thank you.
Hello world, this is me. I'll proceed after my teammate Antonia has given intuition about our project and about the problems we are trying to address. I will go through the technique we have used where is called RAG, Retrieval Augmented Generation, where it is basically allows us to make them all look at documents we have uploaded into our database and then combine these documents, the retrieval one with his capability, and then make a response instead of just making a response based on the data he has trained on it before or the data he has seen it before. And our procedure started with this: collecting legal documents, PDFs, documents from the internet, and clean these documents, clean these PDFs, because these PDFs had a lot of images, a lot of white spaces, a lot of page numbers that are redundant information for the computer, and we are only want the text. So we clean it after collecting it, and then for every PDF we divide it into a chunks, and for each chunks we divide it into a vector of numbers to capture the essence of these chunks and know the meaning of these chunks, and all of this by text embedding OO4 model. And then the user will ask a question. We will convert this question into a vector of numbers again by the same model and try to find the similarity between this vector and all of the vectors of the chunks in our vector store database. And the most relevant chunks, in our case here we have made three, the most three chunks, most similar ones will be retrieved and fed into the model to combine it with his capability and generate a response. And this similarity could be made by these three functions. One of them, relative distance, cosine similarity in a product. After we retrieve the top three relevant chunks based on the similarity, we feed into the LM model and then combine it with the capability, giving us a response. And that's it. That's the notion of what we have used. And man, if you don't know what is the vector and how it capture the essence and all these weird things, let me just give you an intuition. So if we have adjustment equal to 21, that's called a scalar because we have only one number, aka we have only one information. I know one information about adjustment, which is 21. It doesn't really matter for me to know what is 21 stands for, but for just the human interpretation, I will say that 21 is for age. Mina equal to 3, 3 maybe for his GPA. So in conclusion, we only know one information about Jasmine, about Mina, about Sarah, and so on. That's called a scalar. But what is a vector? A vector is more information, more numbers about the same thing. So here we know 4 information about Maya instead of only 1 information in case of Jasmine, Mina, Sarah. And it doesn't really matter for the computer to know what is 24 stands for, what is 3.5 stands for, but only for just the human interpretation, as explanation. I would say that 24 for age, 3.5 for GPA, and so on and so on. But in the computer, in reality, computer doesn't care any much about these labels. And in a vector store, all these vectors are stored in a vector store like this instead of the normal database. That's the I hope you have now an intuition about how, when I told you the vector of numbers capture the essence of the chunks because we have a lot of information about these chunks. Like here, it converts it into 768 numbers. So we have 768 information about these chunks. So I think that's enough to capture the essence and the meaning of these chunks. Let's proceed to our tag notebook. We have here our rights data, two subfolders, space rights and label rights, which contains PDFs as well. Phase one, which we have collected and extract text from PDF, clean it, and phase two, which we set up as an embedding, convert this document into chunks, and from chunks divide it into chunks, and from chunks into a vector of numbers to capture the essence and to make the similarity, and then store it into a vector store. And for this, we have used this function that we have defined building this model, and we have load our database, used Chrome database to add our vector store and store all of our documents into it. Basically, where we will use the same function to embedding this query, but instead of storing it, we'll just query you. Like we'll say, man, okay, this is our vector of numbers. What is the relevant chunks in your database to retrieve it? And we will get the three relevant ones. And then we have the prompt to guide our model with examples and with like a regular prompt. And then put our question here, retrieve all of the passage, all of the chunks that are relevant, and using this model, Gemini, flash, and then we have the answer. At phase four, where we just make a chatbot, but all of the function I have used in phase two and phase three are the same. I'll just here wrap it into a function so I can use it a lot. And I can use it into a while loop to run the chatbot until you leave the chat. He was trying to make him have a brain by making task like a letter, giving him the task, filled into this task, and giving him the prompt. You are a compassionate legal assistant who writes clear professional letters. And we have our layers. We also, just to shorten our time, making a just roadmap by this function by giving him a different prompt. And for the last one, we like trying to make him someone who will guide him in the real world based on some keywords. Like if the user didn't have enough money, is fired, let's say he has enough money, so I suggest to the model to tell him, no worry, man, there is a message or free legal aid. You will be fine on all of these good words. This function to just feed all of this variable into it, and run more code turn. We make a function to run this simulation with a different prompt, and then we will have our loop that will run forever to make the chatbot until we leave the chat. So I can just like run it again and give me, yeah, okay. And yeah, luckily it works. Our judge will try to calm us down and ask me a question to give me the right situation, the right answer, and the right things I have to do, and then give me helpful tips. And here just we say like he's saying, okay, I have got all of this from chunks 1, chunk 2, and chunk 3. I have got this information and this response. I supplied my knowledge from these chunks. So yeah, that's it. I will now leave the chat and the end. Thanks for watching and thanks for reading. Goodbye.